Hello everyone, I hope you guys are doing well and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session, we learn how to perform insertion and deletion operations in a circular doubly linked list. Now both insertion and deletion in a circular doubly linked list requires careful handling of the pointers to ensure that the circular structure of the list is maintained. So in this session, we will provide you with a hands-on tutorial on how to perform insertion as well as deletion in a circular doubly linked list using C++. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Well, so as you can see, Visual Studio Code has started. Now, certainly, before diving into the specifics of insertion and deletion in a circular doubly linked list, let's just first discuss what a circular doubly linked list is. Now, a circular doubly linked list is a type of linked list where each node has a pointer to both its previous and next nodes, and the last node of its list points to the first node, creating a circular structure. So this means we can traverse the list forward or backwards, and we can also go from the last node to the first node. Now, when I talk about insertion in a circular doubly linked list, insertion in circular doubly linked list involves adding a new node to the list. Now, this can be done at various positions, just like any other linked list, like at the beginning, at the end, or at a specific position. So while inserting a new node, we need to update the pointers of the existing nodes to include the new node. So let us write the code for this and see how it is implemented. So firstly, include all the header files, #include iostream, and using namespace std. Alright. So as usual, we will define a node structure for our linked list. So struct node So we will pass a data which will store the value in the node, and we'll create a pointer which points to the previous node. So node * previous, and a pointer to the next node. So node next. Alright. Next we will define a class for our circular doubly linked list. So let us take a class. Let's say its name is Circular Doubly Linked List. So you can give your own name as per your choice here. So inside that we will create a private member function wherein we will pass a head pointer. Alright. So node * head. And then we will create another public member function wherein we will create a constructor to initialize our circular doubly linked list. So mention the class name, which is circular doubly linked list, and now initially the head will point to the null in the linked list, right? So head is equals to null value. Alright. Now firstly, let us create a function to insert a node at the beginning of the list. So for that I'm taking void. Let the function name be insert at beginning. Alright. And inside that I'm passing a parameter which will store the value into our node, which is int data, which is of type int. Alright. Now inside that we will create a new node with the given data. So node * new node is equals to new node. Now this new node points to the pointer of the data, right? So new node of data will store the value in that particular node. So new node of data is equals to data. Now firstly we have to check if the list is empty or not. So if the list is empty, we will set the head to the new node. So the condition for that would be if head is equals to null. So in such case, head will become the new node, and head of previous will become the head node, and similarly head of next will also become the head node as well. Now since the list is empty, this will be the condition for it. So head of next is equals to head. and we will return the list. Alright. Now this is the condition if the list is empty. Now we have to create another condition where if the list is not empty, we will insert the new node at the beginning, right? So for that, the code would be, let's take a new node. So the new node's previous pointer will point to the head of previous node. So new node of previous will point to the head of previous pointer. So I hope you understood. So the last node's next pointer will point to a new node as it will be the new head next. So new node of next will become the head here. There is a mistake in spelling, so let's just correct that. So next, head of previous pointer of the next pointer will become the new node here. So the current head's previous pointer will point to the new node as it will become the new head node now. So next, head of previous will become the new node. So head's previous pointer will become the new node. So I hope you understood this. So this is basically the function to create a position, that is to insert a value at the beginning of our circular doubly linked list. Now let us now create another function which will insert position at a given point. So it can be at any position. So for that I'll take another function which is void. So I guess we haven't created a function for inserting a value at the end. So first let us create that. So next we can go on to the insert at a particular position. So I'm creating a function to insert the value at the end of the circular doubly linked list. So for that I'm passing a function insert at end and a parameter of data type which is of int type. So again the process is same. We will create a new node with the given data. So node asterisk new node and new node of data will become the new value into the particular node. So new node of data is equals to data. So again we will check if the list is empty. If the list is empty, we will set the head to the new node. So if head is equals to null, so in that case head will become the new node. And head of previous, so head's previous pointer will point to the head node again. Similarly, head's next pointer will also become the head. Now since it is a circular linked list. So otherwise, if the list is not empty, we will insert the new node at the end. So for that, the code will be new node of previous will become the head of previous. So new node's previous pointer will point to the head of the previous pointer. And new node's next pointer will point to the head here. So new node of next is equals to head. And head of previous pointers next will become the new node. Alright. And finally, head's previous pointer will become the new node again. Since it is in the second, it will become the second new node. So head's previous is equals to new node. So I hope you understood this. So this is basically the code to insert a value at the end of our circular doubly linked list. Alright, let us now create a function to insert the values at a certain position in our circular doubly linked list. So for that, the code would be void. Let us take a function name, let's say insert at position. And we will pass two parameters here. But the first one is to store the data, and next one is to locate the position at which we are trying to insert. So I'm taking insert position. So again we will create a new node for this as well. So node asterisk new node is equals to new node. And again new node of data will become the new value. So new node's data points to the data value in our head. So again, let's just check if the list is empty. For that, if the head is equals to the null pointer. So in such case, the head will become the new node. Head is equals to new node, and head's previous pointer and the next pointer will point to the head itself. So head of next is equals to head, and head of previous is equals to head. But if the list is not empty, we are giving else condition. In such case, what we'll do is we will create a temporary node, or let's say a current node, which will store the position of our value. So node asterisk current node is equals to head, and let's say the current position is 1. So in current position, let's take it as 1. So I hope you understood this. Now we have to check the condition whether it is moving forward in the direction of our linked list or not, and where the value is being stored. So let's say I'm taking a while condition here. So if the current position is less than the position that we're trying to insert, as well the current node's next pointer is not equals to head, in that case we will save that current nodes to the next pointer. So what it will be, the code will be is current position is less than our position that we are trying to insert, and I'm taking an AND operator. Current node next pointer, if it is not equals to head. Alright. So in that case, current node is equals to current node of next. Alright, and we will increment the position. So current position will be incremented by 1. So current position, we will increment the value, so we will use plus plus. That's it. That as simple as that. Now we have to store this value, right? So the node's previous pointer become the current node previous pointer. So we'll point to the current node of previous pointer. So the new node, its next pointer will point to the current node here. So new node next pointer will point to the current node. Similarly, new node's previous pointer will point to the previous node. Previous will point to the prev node. Now prev node, its next pointer will point to the new node again, since it will become the second new node. And finally, the current node's previous pointer will become the new node. So current node previous pointer will become the new node. So let's say if the current position is equals to 1, that is the new node is pointing to the head. So we will give that condition here. So let's say if current position is equals to 1, so in that case head will become the new node here. So that is the case for creating a function to insert a value at a certain position. Now we will just print those values. So for that I am taking a void function. You can give it any name. Void, let's take print list. So firstly, if head is equals to null, we will check if the list is empty or not. So if head is equals to null, then we will tell the compiler to say the list is empty. So cout list is empty. Alright, and we will end the line. Return the list as it is. Alright. Now if it is not, if the list is not empty, we will print the values. So the node, current node, that is node asterisk current is equals to head. We will print all the values until we, while the current is not equals to head. So we will print the values until then. So for that we will use a loop which is a do while. So do cout currents of data is current is equals to current of next. Current of next. So this will continue while current is not equals to head again. So we will write a while loop as well. While is not equals to the head node again. So cout and we will end the line. That's it. So we are left with the main function here. So let's just create that as well. So let us declare the main function in main. So we are creating a new circular doubly linked list where we are calling our class which you have taken, and we are passing an object to our class here. So the class we have taken was circular doubly linked list. Doubly linked list. So you can give any name to your choice. So I'm just taking CDL here. So let us now call this object and pass the values into it by calling our functions that we have taken to insert values at the beginning, at the end, and at a specific position. So CDL dot, first we have the insert at beginning. So I am inserting a value, let's say 2. Now again, let's insert another value, CDL dot insert at beginning 1. Now the reason why I have taken first 2 and then 1 is, so firstly if you take 1 and if you try to insert 2, the 1 will be pushed to the second node, and the first node we will have 2. So it will be 2, 1. So instead of that, if you want to have a sequential order of 1, 2, 3, 4, 5 and so on, you have to insert in the reverse direction. So that is, if you want to insert 1 at the first position, so 2 will be inserted first. So similarly, we will insert some elements at the last. So for that, CDL dot insert at end. So let's say 5. We will insert 5 and insert 6 also. So CDL dot insert at end 6. Alright. Now let us try to insert some elements at a specific position. So CDL dot insert at position was the function we have taken. Insert at position. So let's say if I want to insert 3 at the third position. So 3, 3 will be the position. Similarly, if you want to insert 4, the position would be 4, 4. So insert dot insert at position 4, 4. So in this way you can print in a sequential order like 1, 2, 3, 4, 5, 6, wherein 1, 2 will be at the beginning of the circular doubly linked list, and then we have 5, 6 at the end, and 3, 4 at a particular position that we are giving here. So and finally we will print the list. CDL dot print list. So that is our basically the code. So let's just try to execute this and we will see the output. So wait for it to show the result. So as you can see in our resultant output, we have 1, 2, 3, 4, 5 and 6. Now you can insert the values at any position, not just in a sequential way. So let's say if I take CDL dot insert at position. So let's say I'm trying to insert an element 7 at the third position now. So in such case, let's see what will be the output. So you can see 7 has been inserted at the third position now, where previously 3 used to be in that place. So in this way, you can perform insertion at the beginning, at the end, at a specific position in a circular doubly linked list. I hope you understood this. So let us now create another file and try to see how to perform deletion at the various positions in a circular doubly linked list. Now since it's time taking, I'll just copy the code and we will try run the code and see how it is being executed. So let's just go through the code here for deletion of just comment here so that you'll have a better idea of what we're doing. So we're just performing a deletion in CDL at various positions. Alright. So as usual, we are giving the header files and we are defining a node structure where we will create a data that will store the value in our node, and we are creating a next, a pointer to the next which will point to the node, and similarly a pointer to the previous. And again, we are creating a class where we're initializing a head node and we are giving it a size, and we are initializing a constructor where head will be is equals to a null pointer for a new node. And again, we have the insert function where we are trying to insert a particular data at any position. Now comes the main part. Now till here we have discussed in our previous segment of how to insert the values, right? So next we have the deletion, right? Now I am taking a function delete at beginning here. So basically we are taking, first we are checking if the list is empty. So if the head is equals to null pointer, we will return list is empty. Then we have the deletion at beginning code here, wherein we are let's say the last node's next pointer here will point to the heads next, as current heads next will become the new head here, and similarly the previous pointer of the head next pointer which will become the new head will point to the last node here, and finally we will delete that value here, and also head of we'll change head to the pointers next as it points to the new node at the end. Now next we have the delete at end, deletion at the end function here. Again we are checking if the list is empty where head is equals to null pointer, and next again the next pointer of the last node's previous will point to the head, as last node will become the as head to the last node it will become the last node again. So again the pointer's previous node will become the last node, hence head's previous pointer will point to it, and we are deleting the temporary value that here. And similarly we are creating a function where we are creating a function and deleted at a certain position. So again we are taking a POS which is position. So we are checking if position is less than or equals to 0 and position is greater than the size that we are taking, we will return it as an invalid position. But if the position is equals to 1, we will say that delete at beginning. Now what if the deletion should be done at various other positions? So for that I'm creating a for loop where I'm initializing a variable I, int I is equals to 1. If I is less than POS and I++, we will store the temporary value which will point to the next node. Alright, so this is the code for this, and again in order to print the list we are taking a display function here, and finally we are creating a main function here where we are trying to insert some values first and then we are displaying that list, and then we will perform a deletion operation at the beginning. So let's say 10, 20, 30, 40, 50 are elements. So if we perform deletion at the beginning, 10 will be deleted. Now similarly we are performing deletion at the end, so 50 will be deleted here. And similarly at position, now list after deleting at position 2. So we are giving a deletion at position 2, that is after deleting 10 and 50 we have 20, 30 and 40, right? So the second position will become 30. So only 20 and 40 will remain in our final list. So let's just run this statement and we will see if the output is same or not. So as you can see, the original list is 10, 20, 30, 40. After deleting the element at the beginning, we have 20, 30, 40, 50 since we are deleting the element 10. Next we are deleting at the end. So 20, 30, 40 since you have deleted 50 at the end here. Next we are deleting at the position 2. So 20, 30, 40. So second position is 30. So 30 is eliminated from our list. So only 20, 40 are remaining after deleting at that particular position. So in this way you can perform deletion as well. Now if you have any further queries on this code, we will leave in the description below so you can check that out. And if you are having any further queries regarding the code or the implementation, you can feel free to let us know your opinions and thoughts in the comments. We will try to resolve it as soon as possible. So I think with that we have come to the end of today's session, wherein we have covered the insertion and deletion operation on a circular doubly linked list. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further questions regarding any of the topics covered in today's tutorial, feel free to let us know in the comments below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content, and if you want to learn more about data structures, we have a dedicated playlist on our channel, so make sure you check that out, and we will leave the link in the description as well. Until next time, thank you and keep coding.